The equations work. Every single one of them. The math is clean, the logic is airtight. And what it tells us is that time travel is legal, that you are probably immortal, that this reality almost certainly isn't real, and that the universe is statistically more likely to have invented your brain on accident than on purpose. Let's go. Number 10, the grandfather paradox. You travel back in time. You find your grandfather before your parent is born. You stop him from ever having children. Your parent never exists. You never exist. You were never born. You never traveled back in time. Your grandfather lives. Your parent is born. You exist. You travel back in time. Repeat. Forever. Here is what makes this more than a thought experiment. Einstein's field equations do not forbid time travel. Formally, physicist Kurt Gödel proved in 1949 that certain solutions to general relativity allow for closed time-like curves, paths through space-time that loop back on themselves. The math does not break. It works perfectly. That is the problem. Scientists tried to escape it. Stephen Hawking proposed the chronology protection conjecture, the idea that nature conspires to prevent time travel because of paradoxes like this one. But that is not a law. It is a wish. There is no mechanism, no equation that enforces it. Other physicists tried the Novikov self-consistency principle. You can travel back in time, but you can only do things that already happened. The timeline is a fixed loop. You have no free will inside it. Think about that. If time travel is possible, free will may be mathematically forbidden. The universe doesn't allow you to change anything, only to fulfill what was always going to happen. And no one can tell you why. Number 9, the Fermi Paradox. The Milky Way is 13.6 billion years old. It contains between 100 and 400 billion stars. Conservative estimates place the number of Earth-like planets in our galaxy alone at 40 billion. The universe has been running this experiment for most of its existence. Even if intelligent life emerges around just 1 in a million suitable planets, our galaxy should contain tens of thousands of civilizations, many of them millions of years older than us. Where are they? In 1950, physicist Enrico Fermi sat down at lunch and did the math. The numbers are undeniable. A civilization even a few thousand years ahead of us could colonize the entire galaxy in under 10 million years, using ships that travel at just 1% the speed of light. That is cosmically trivial time. The galaxy should be full. The radio bands should be screaming with signals. There is nothing. Scientists tried every explanation. Maybe they're hiding. Maybe they destroy themselves before they can expand. Maybe interstellar travel is impossible in practice. Maybe they're using communication methods we haven't invented yet. But here is the implication no one wants to say out loud. The silence may mean there is a filter, some step in the development of intelligent life that almost nothing survives. Either we already passed it, and we are the miracle, or it lies ahead of us, and we don't know which. If the universe is filled with dead planets, we are living on borrowed time. Number 8. The information paradox. Everything you are is information. Every atom in your body, every relationship between those atoms, every quantum state that makes you you, it is all encoded in the physical universe. And one of the most fundamental laws of quantum mechanics says that information cannot be destroyed, not compressed, not hidden, destroyed. The universe forbids it. Then a black hole forms. Black holes devour everything that crosses the event horizon. Nothing escapes. Not light, not matter, not signals of any kind. Stephen Hawking showed in 1974 that black holes do slowly evaporate. They radiate thermal energy now called Hawking radiation. Over trillions of years, a black hole loses mass and eventually disappears. Here is the problem. Hawking radiation is random. It carries no information about what fell in. When the black hole is gone, the information is gone, truly gone, which is illegal. This isn't a philosophical quibble. This breaks quantum mechanics at the foundation. The two most successful theories in physics, general relativity and quantum mechanics, directly contradict each other here. One of them is wrong. For 40 years, the best minds in physics tried to solve this. Hawking himself fought it his entire career, eventually conceding ground. The leading candidate today is the holographic principle, the idea that information is somehow encoded on the surface of the event horizon, not inside. But this requires that three-dimensional space is a projection of a two-dimensional surface. Reality is a hologram, and even then, no one has proven it. The information paradox remains open, and its implications are worse than the problem. Number 7. The measurement problem. An electron is fired at a barrier with two slits, No one watches. It passes through both slits simultaneously, interferes with itself, and lands in a wave-like pattern on the detector. This is not metaphor. This is the measured result replicated billions of times. Now someone watches which slit it goes through. The interference pattern disappears. The electron picks one slit, behaves like a particle. The act of observation collapsed the wave function. This has been tested with electrons, photons, buckyballs, molecules of 60 carbon atoms. A molecule the size of a small drug compound exists in superposition. Until you look, here is what no one agrees on. What counts as observation? A camera? A conscious human? An unconscious detector? Does it require a mind? The universe is 13.8 billion years old. Humans appeared 300,000 years ago. Was the electron behaving strangely for 13.8 billion years before we showed up to notice? Physicists have fractured into camps. Copenhagen says the wave function collapses upon measurement, but refuses to define what measurement is. Many Worlds says it never collapses. Every outcome happens in a branching universe. Pilot wave theory says hidden variables guide the particle all along. They all reproduce the same predictions. They all describe a completely different reality. The most dangerous experiment in physics produces results everyone agrees on, and a theory no one agrees about. After 100 years, we do not know what happens when you look at something. That is not an exaggeration. That is the state of physics. Number 6. The arrow of time paradox. You know time flows forward. You have never watched a broken egg reassemble itself. You have never seen smoke rush back into a cigarette. Cause comes before effect. Memory points backward. This feels as obvious as gravity. The laws of physics disagree with you. Every fundamental equation in physics, Newton's laws, Maxwell's equations, Einstein's relativity, Schrödinger's wave equation, is time symmetric. Run them forward. Run them backward. They work identically. There is no arrow. There is no preferred direction. If you filmed 2 billiard balls colliding and played it in reverse, the physics would be legal. The only exception is the second law of thermodynamics. Entropy increases. Disorder grows. But this is a statistical law, not a fundamental one. It says probably not always. Given enough time, a broken egg could spontaneously reassemble. The probability is just so absurdly small that it has never happened in the observable universe. But here is the crisis. If the laws of physics have no direction, and entropy is just statistics, then the arrow of time is not a law. It is a coincidence. We experience time moving forward because we started in an extremely low entropy state, the Big Bang. We are coasting on that initial order, which means time as you experience it is not fundamental. It is a side effect of an accident 13.8 billion years ago. And in a universe old enough, time will stop having a direction altogether. There is nothing in the equations preventing it. Number 5. The fine-tuning paradox. The universe has 26 constants, numbers baked into reality at the moment of creation: the speed of light, the strength of gravity, the mass of the electron, the cosmological constant. They don't come from any equation. They are simply set, and they are set with terrifying precision. If the strong nuclear force were 2% weaker, protons wouldn't bind. No atoms. If the cosmological constant, the energy of empty space, were larger by 1 part in 10 to the power of 100, and 20,000 universe would have expanded too fast for gravity to form anything. Not just no life, no stars, no galaxies, no structure, just a cold, thin fog of particles racing apart forever. 1 part in 10 to the 120th. To appreciate that number, there are estimated to be 10 to the 80th atoms in the observable universe. The fine-tuning of the cosmological constant is more precise than picking one specific atom from a universe-sized pile, 10 trillion times over. Scientists have 3 answers. First, God. Second, the multiverse. If there are infinite universes with random constants, we happen to live in the one where the numbers work, because we couldn't exist to ask the question otherwise. Third, there is an undiscovered deeper law that forces these values. Every answer is uncomfortable. The multiverse is untestable by definition. An undiscovered law means we know nothing. And the first answer is the one physics has spent 3 centuries trying not to need. None of the 3 are settled. All of them change everything. Number 4. The simulation paradox. In 2003, philosopher Nick Bostrom published a paper that has not been disproven. It presents 3 possibilities. 1. Civilizations almost always destroy themselves before reaching the computational power to run realistic simulations of conscious beings. 2. Civilizations with that power choose not to run such simulations. 3. We are almost certainly living inside one right now. The logic is pure probability. If even one civilization in history reaches the technology to simulate conscious minds, and runs those simulations at scale, the number of simulated minds will dwarf the number of real ones by billions to one. You are statistically more likely to be simulated than real. Physicist Silas Bean ran calculations in 2012 suggesting that simulated universes would have detectable artifacts, energy cutoffs at the highest cosmic ray frequencies, because any simulation has resolution limits. A grid, the observable universe, has a cosmic ray energy cutoff at approximately 5 times 10 to the 19th electron volts, right where a simulation would need to cap it. He did not say this proves we're simulated, but it doesn't disprove it. Here's what keeps the physicists awake. If this is a simulation, the simulator exists outside our physics. Our laws mean nothing to them. They can pause it, edit it, end it. Every prayer ever uttered was aimed at the right address, and we have no way to reach back, no way to ask, no way to verify. We are, potentially, someone else's experiment, and they have not chosen to tell us. Number 3. The quantum suicide paradox. The many worlds interpretation of quantum mechanics says this: the wave function never collapses. Every quantum event that can go multiple ways does go multiple ways, in branching parallel universes. When you flip a coin, a universe exists where it landed heads, and a universe where it landed tails. Both are real. This sounds abstract. Physicist Max Tegmark made it personal in 1997. Imagine a quantum gun. It fires or misfires based on the quantum spin of a particle, a genuinely random 50-50 event. You point it at your head and pull the trigger. In many worlds, 2 branches split, one where it fires, one where it misfires. The version of you that experiences anything is the version in the branch where it misfired. From your subjective experience, it always misfires. You are, from your own perspective, immortal. You will always find yourself in the branch where you survived. This is not a metaphor. This is what the mathematics of many worlds predicts if you take it literally. Every physicist who accepts many worlds and is honest about it has to reckon with this. You have survived every near-death experience not because you were lucky, but because you could not have experienced the alternative. The terror is not the immortality. The terror is what it implies about everyone else. The universe does not protect them. Only you. The people you love exist only in branches where they survived. In the branch you're in right now, some of them are already gone, and you have no idea which branches you've already left behind. Number 2. The Bootstrap Paradox. A time traveler arrives in the past and hands Beethoven the complete sheet music for the Fifth Symphony. Beethoven had never written it. He copies it, performs it, it echoes through history, and eventually the time traveler learns it, travels back, and hands it to Beethoven. Where did the music come from? This is not science fiction. This is a formally valid solution to the equations of general relativity. A closed information loop, an object or piece of information with no origin point. It was never created. It simply exists, passing from future to past to future, with no beginning and no end. The problem is causality. Every effect requires a cause. The Bootstrap Paradox produces effects with no cause. The symphony was never composed. It bootstrapped itself into existence. Physicist Igor Novikov's self-consistency principle permits this. As long as the loop is consistent, the physics is legal. But here is what this actually implies. If closed time-like loops exist, there may be information in this universe, real physical information, that has no origin, knowledge with no source, objects with no maker. The laws of physics allow for things to simply exist, uncaused, in defiance of everything we believe about reality. And there is no way to tell from the inside whether the history we think we know is original or a loop, whether the universe we see is the first version or the 1000th. We are inside the circle, we cannot see the outside, and there may not be one. Number 1. The Boltzmann Brain Paradox. In an infinite universe with infinite time, quantum fluctuations will eventually produce every possible arrangement of matter, every configuration, including, with probability exactly equal to one given infinite time, a fully formed human brain, complete with false memories of an entire life, popping into existence for one moment from the void before dissolving back into chaos. This is called a Boltzmann brain, named after physicist Ludwig Boltzmann, who first derived the statistical mechanics that make it not just possible but inevitable, given enough time. Here is the crisis. A Boltzmann brain is far simpler to produce by random fluctuation than an entire ordered universe with consistent physics and billions of years of coherent history. Far, far simpler. Which means in a truly infinite universe, Boltzmann brains vastly outnumber beings like us, beings with real memories, real histories, real environments. If you are a statistical observer in an infinite universe, you are almost certainly a Boltzmann brain. Your memories of childhood are false. The laws of physics you observe are a local fluctuation. In the next moment, the fluctuation ends, the coherence collapses, and the brain dissolves. You would never know. You would feel completely normal right up until the moment you ceased. The fact that you are currently experiencing a coherent, continuous reality with consistent laws is not strong evidence that you're real. A Boltzmann brain would experience exactly the same thing. Physicists call this a catastrophic failure of cosmological reasoning. They have no solution. The math simply refuses to rule you out. 10 paradoxes, 10 places where the equations work perfectly and reality falls apart. Time has no direction. Information may not exist. You may be a simulated thought inside a machine that has already been switched off. You may be a random brain in a void, lasting 1 second before the void reclaims you. The universe did not give us these answers. It gave us the questions, and it made them unanswerable on purpose. If you want to see more videos like this, click the video on screen now.